All right, just number 4. How do you count sigma in pi bonds? So how do you count sigma in pi bonds? So if we want to figure out a sigma or pi bond, we have to actually figure out what kind of bond is it first, and then we have to figure out the hybridization, and then we can figure out the number here. So if you had, for example, a straight chain alkane, so let's say a butane, for example, this here represents the carbons here, or all the carbons here in this example, are sp3 hybridized. Which means that what it means that carbon can make 4 bonds, which means it can make what we can do is we can make we're gonna have sigma bonds here. So sp3 represents sigma bonds, and that depends on how many bonds, and the number of sigma bonds depends on how many bonds the carbon's making. So for example, this carbon here is making 1 bond to the carbon, which means it has 1 sigma bond. However, this one here is making carbons to 1 and to 2, so this one will have 2, this one has 2, this one has 1, and that one has 1. So that's how we can count sigma bonds in this case here. If we had a double bond, for example, so let me bring out butene. The carbon here, or the double bonded carbon here, is going to sp2 hybridized. Well, what does that mean? Well, it means that I have the existence of 1 pi bond, and I also have 1 sigma bond. And the reason why is that the pi orbitals are actually going to the pi bonds are basically orbitals overlapping each other, and this actually creates a trigonal planar type of geometry according to Vesper. So this here was sp3, so we can make 4 bonds, so this is tetrahedral. This one is, according to Vesper theory, would be kind of like a trigonal planar kind of type of geometry here. So in this case here, that's why they have double bond here. So it actually kinks. It creates a kink in the hydrocarbon chain. If we want to count sigma and pi bonds, a double bond contains 1 pi bond, and the other contains a sigma bond here. So we have 1 pi bond and 1 sigma bond. So 1 pi bond on this side and 1 pi bond on this side. And these guys can overlap because it depends on the rotation of the bond as well. So there's that. And then finally, in a triple bond, example of a triple bond, this is going to be sp hybridized, which means that this here contains 2 pi bonds. 2 pi bonds. So 1 on this side and 1 on this side. And the pi bonds are actually going to even themselves out, which means this geometry here is linear geometry. So 2 pi bonds and a linear geometry here. So as you can see, this triple bond contains 1 sigma and 1. They all contain sigma bonds because depending on the sigma bonds actually kind of hidden in this third bond here, but the outside is the pi bond as well. So 2 pi bonds and 1 sigma bond. So that's kind of our solution for this problem here. So again, you can think of it as in the sp3 hybridized, there's 1 sigma bond. In a sp2 hybridized, there is 1 pi and 1 sigma bond. And then finally, sp hybridized has 2 pi bonds and 1 sigma bond. So it depends on the hybridization, and we can verify this using Vesper theory as well. So the solution is correct.